Ever wondered what happens before sugar hits your table? While many think of tropical cane fields, there's an unsung hero growing right beneath our feet: sugar beets. These remarkable root vegetables are agricultural powerhouses, with American farmers harvesting a staggering 36 million tons annually, supplying nearly 60% of America's domestic sugar. Their journey from soil to sweetener is a marvel of modern farming innovation that few ever witness. In this comprehensive guide, we've broken down the entire sugar beet journey into 4 fascinating sections. First, we'll explore the meticulous soil preparation and precision planting techniques that set the foundation for a successful crop. Next, we'll reveal the cutting-edge plant care technologies ensuring optimal growth in diverse climates. Third, we'll showcase the impressive harvesting machinery that's revolutionized how these crops are collected. Finally, we'll take you inside the sophisticated processing facilities where beets transform into the crystalline sweetener we all know. By the end, you'll never look at sugar the same way again. Section 1. Soil Preparation and Planting. Sugar beets power America's $20 billion sweetener industry, thriving everywhere from California's sunny valleys to North Dakota's chilly plains thanks to smart farming techniques. Modern farming starts with high-tech soil testing. Farmers use digital sensors to check soil pH, nutrients, and moisture levels, boosting yields by 15%. The perfect sugar beet soil needs a pH between 6.0 and 8.0 and excellent drainage to prevent root rot. Today's farmers use GPS-guided plows that maintain precise soil depth across hundreds of acres, creating uniform growing conditions while mixing in organic matter to improve water retention. They apply custom-blended fertilizers designed specifically for sugar beets, with controlled release formulas that feed plants gradually while reducing environmental runoff. Planting happens with computer-controlled seed drills that place each specially coated seed exactly 2.5 centimeters deep and 20 centimeters apart. These protected seeds grow faster and stronger, with advanced varieties maturing in just 170 days while needing 30% less pesticide than older types. Section 2. Plant care and growth. Once sugar beets take root, they enter a critical growth phase requiring constant monitoring and precise intervention. What once relied on farmer intuition has evolved into a data-driven science. Today's sugar beet fields are equipped with IoT, Internet of Things, sensor networks that measure soil moisture at multiple depths, tracking how water moves through the soil profile. This data feeds into automated irrigation systems that activate only when specific moisture thresholds are reached, conserving water while preventing both drought stress and oversaturation. The irrigation systems themselves have undergone remarkable evolution. Center pivot systems, equipped with variable rate technology, can adjust water flow based on topography and soil type variations across a single field. The most advanced operations have integrated weather forecast algorithms that proactively adjust irrigation schedules based on predicted rainfall patterns. Some farmers have reported water usage reductions of 25 to 40% after implementing these smart irrigation systems, addressing growing concerns about agricultural water consumption in drought-prone regions. Nutrient management during the growth phase has become equally sophisticated. Drone-mounted multispectral cameras regularly scan fields to detect early signs of nutrient deficiencies through leaf color analysis. These images create detailed prescription maps, guiding variable rate fertilizer applications. Rather than treating entire fields uniformly, farmers can now target specific zones with precisely what they need, reducing fertilizer costs while minimizing environmental impact. The nitrogen efficiency of modern sugar beet operations has improved by nearly 35% over the past decade through these precision agriculture techniques. Disease and pest management represents another area where technology has transformed sugar beet cultivation. Early detection systems using artificial intelligence can identify the presence of Cercospora leaf spot and powdery mildew, 2 devastating beet diseases, before symptoms become visible to the human eye. This early warning allows for targeted treatment of affected areas rather than broad-spectrum application across entire fields. Integrated pest management programs have further reduced chemical interventions by introducing beneficial insects and establishing crop rotation protocols that naturally break pest life cycles. Throughout the growth phase, which typically spans 5 to 8 months depending on climate and variety, sugar beets develop their characteristic large, pale roots. Inside these roots, the plants concentrate sucrose at levels reaching 17 to 20%, significantly higher than the 12 to 14% found in sugar cane. As harvest approaches, farmers begin monitoring sugar content using field refractometers, timing their harvest to coincide with peak sugar concentration. This precise timing can increase processable sugar yield by 3 to 5%, a significant economic advantage in an industry with thin profit margins. The final weeks before harvest often involve curing the beets through strategic irrigation management. By slightly reducing water availability, farmers trigger the plants to convert more nutrients into stored sugar. This practice, refined through decades of agricultural research, maximizes sugar content without compromising root weight. The sophisticated balance between growth promotion and sugar concentration represents one of the most delicate aspects of sugar beet cultivation. Section 3. Harvesting. Modern machinery in action. The sugar beet harvest showcases some of agriculture's most impressive technological achievements. After months of growth, these valuable roots, now weighing up to 5 pounds each, must be extracted with minimal damage to preserve sugar content. The days of manual harvesting have given way to specialized machines representing engineering marvels worth examining in detail. Modern harvest begins with defoliation, the precise removal of the leafy green tops rather than simple cutting. Today's defoliators use counter-rotating steel flails calibrated to remove foliage without damaging the crown of the beet. The most advanced models incorporate optical sensors that adjust cutting height based on individual plant characteristics, reducing waste while maximizing harvestable material. This foliage doesn't go to waste. It's either returned to the soil as green manure or collected for livestock feed, containing valuable nutrients and fiber. Following defoliation, massive harvesters weighing up to 60 tons enter the fields. These engineering marvels can process 12 to 16 rows simultaneously, extracting up to 1,200 tons of beets daily. Their operation is a symphony of coordinated systems. Vibrating shares loosen soil around the beets. Hydraulic lifters raise them with minimal damage, and cleaning turbines remove soil through controlled agitation. The latest harvesters incorporate rubber-coated components that reduce impact damage, preserving sugar content during the extraction process. GPS guidance systems ensure these massive machines maintain perfect alignment with planted rows, reducing missed beets while preventing soil compaction between rows. The cleaning systems within modern harvesters deserve special attention. Multi-stage turbines use combinations of rotating drums, pressure-controlled airflows, and specialized rollers to separate beets from soil without damaging the valuable roots. Some machines recover over 98% of viable beets while removing up to 90% of soil before transportation. This cleaning efficiency significantly reduces transportation costs and processing energy requirements at the factory. The most advanced models can adjust cleaning intensity based on soil moisture conditions, applying gentler action in dry conditions and more aggressive cleaning in muddy fields. After cleaning, sophisticated sorting systems evaluate each beet for size, damage, and potential sugar content. Optical scanners can process hundreds of beets per minute, redirecting damaged specimens toward alternative uses. The harvesters then transfer clean sorted beets to transportation vehicles through extended boom conveyors that can reach up to 45 feet, allowing trucks to remain on field perimeters rather than driving through planted areas and compacting soil. The logistics of harvest timing represents another critical factor. Once harvested, sugar beets begin losing sugar content immediately, approximately 0.1% per day. To maximize yield, Harvesting operations run continuously during optimal weather conditions, often 24 hours, using harvesters equipped with LED lighting arrays and night vision guidance systems. The largest operations coordinate multiple harvesters and transport vehicles using centralized logistics software that optimizes field coverage and minimizes wait times. Some regions now employ cooperative harvesting models, where farmers share equipment and coordinate harvests to maximize equipment utilization and processing efficiency. Climate change has introduced new challenges to the harvest timeline. Increasingly unpredictable weather patterns have shortened optimal harvesting windows in many regions. In response, equipment manufacturers have developed faster, more efficient machines capable of harvesting greater acreage during favorable conditions. Some operations now utilize predictive analytics, combining historical weather data with forecast models to optimize harvest scheduling across thousands of acres. Section 4. From Farm to Table. The Sugar Factory Magic. After harvest, sugar beets race against time to reach nearby factories. Modern GPS tracking ensures they travel quickly, usually less than 30 miles, preserving maximum sweetness along the way. At the factory, high-tech scanners instantly measure each beet's sugar content without damaging them. Farmers love this fair system since they're paid for sweetness, not just weight. The transformation begins with powerful washing systems that clean beets using recycled water. Then, laser-guided slicers cut them into perfect V-shaped strips that maximize sugar extraction. Hot water flows through these strips in the opposite direction, cleverly dissolving an impressive 98% of the available sugar while using minimal energy. The resulting sugar-water mixture gets purified when lime and carbon dioxide capture impurities. Special evaporators then remove water through an energy-efficient chain reaction before the liquid enters vacuum chambers for crystallization, where tiny seed crystals grow into perfect sugar crystals under precisely controlled conditions. High-speed centrifuges spinning faster than car engines separate these crystals from remaining liquid. After computer-controlled drying and cooling, the sugar is sorted by size and packaged, up to 1,000 bags per hour. The sustainability story is equally impressive. Modern factories generate their own electricity, convert leftover pulp into renewable biogas, and recycle nearly all their water. Who knew making something sweet could be so smart and green? Final words. From precisely planted seeds to the crystalline sweetener in your pantry, sugar beets represent one of agriculture's most remarkable technological success stories. This incredible journey demonstrates how cutting-edge innovation continues transforming even our most fundamental food systems. American sugar beet farming doesn't just feed our sweet tooth. It showcases sustainable agriculture's future through water conservation, precision application, waste reduction, and energy efficiency. Next time you stir sugar into your coffee or enjoy a sweet treat, remember the extraordinary journey that brought it to your table. From the farmers operating sophisticated equipment to the engineers designing ever more efficient processing systems, the sugar beet industry exemplifies how modern agriculture continues evolving to meet growing global demands while reducing environmental impact. If you've enjoyed this deep dive into sugar beet production, don't forget to like this video and subscribe to Smart Farming Inside for more behind-the-scenes explorations of the foods we consume every day. Drop your questions in the comments and let us know which agricultural process you'd like us to explore next. Until then, this is Smart Farming Inside, helping you understand the incredible journey from field to table.